Okay, so everything up to now is to find either the exact value, right? 2 classes ago, finding exact value, or find angle. So you go backwards. Okay, so make sure you remember 1, 2, 3, 4, 4, 3, 2, 1, right? The 4 steps. When to use the draw angle first, when to check sign first. Okay, make sure you don't mix those up. So now to extend this idea, okay? So for example, like we'll go back to page 41. Okay, you can look at page 41 or look at the screen. This is to find exact value if they tell you the angle. Okay, so for example, we can go over one question first, okay, as a review. So here they give you the angle. Okay, you can turn to page 41. I'm gonna work on this one. So I want to find the exact value for this one, right? So our step 1 is to draw the angle, right? So draw it out. 30° is in first quadrant, so draw that out, right? This is your step 1. Step 2 is to get the reference angle. So look at the picture, our reference angle is 30°. Okay, and then step 3 is to fill in the sides, right? So for 30°, how long is the opposite side? Evan? If the reference angle is 30°, how long is the opposite side? Evan?
It's root 3.
Nope. Look at the picture, it's on page 41 on the top, right? If it's 30°,
Oh, it's 1.
yeah, okay, 30° is the smaller angle, right? Opposite side will be the shorter one, it will be 1, okay? If it's a 60°, it will be the root 3. Just remember the opposite side, right? Then you won't get mixed up. So the other two sides will be root 3, root 3 and 2, right? So that's a side, and then we are looking for the ratio. So we have sine 30° equals to what over what, Jenny?
One over 2.
Yep, opposite is 1, hypotenuse is 2, okay? And then we still have step 4. We need to check the sign, okay? Positive or negative? Marcus?
So what is that?
Is it positive or negative for this question?
Positive.
Yep, okay, it's in quadrant 1, right? So everyone will be positive, so that's your answer, right? This should be review. So they give you the angle, okay? You find the ratio. Ratio, angle. Okay, so every time you have an angle, you should be able to get a ratio. So we call the angle the input. Okay, and then you get an answer, we call that an output. Okay, input and output. You input an angle, you get a ratio out. So all the input, we can use the variable x. All the output, we can use the y to represent. So every angle, you get a ratio. Every x, you get a y, right? So when you have a pair like that, it's like having a point on the graph. So therefore, if I keep on plotting, right, with different angle, different ratio, then you can connect all the points and then you get a function graph. Okay, so that's where the graph comes from. Okay, every angle, you get a ratio out. Okay, so each angle is the x, each ratio is the y, then you get a pair. So for this one, you can think of it as a point, 30° and 1 over 2, okay? That's a point. So angle is the x, ratio is the y. Okay, so that's gonna connect us to our new topic on the next page, right? So we are on page 46. So here you have X and Y now, right? So here with the graphing, right? This is called trig function, trigonometric functions. So function means you can graph, okay? Means you have X and Y points, right? X, you put X into the function, you get a Y out. So you can graph. So whenever you see the word function, it represents a graph. So like I said just now, right, the X here is your angle, right? Your Y is your ratios, okay? And then with each pair of points, we can plot them, all right? So here we have a table, right? Table of values. So each X is the angle, we'll write that one more time. Each Y is the ratio. Okay, we just did our 30 degree, right? 30 degree, which is the same as power 6. So that's this one, right? 30 degree, we have a ratio of 1/2. Some of the main ones, okay? We are just gonna plot the main ones. The 0 degree, oops, not this highlight, okay? I'm gonna highlight that. This one, okay? Power 2, right? That's on the y-axis, right? And pi. And then this one, 3 power 2 and 2 pi. So total of 5 points, okay? That's what you should be focusing on, all right? So we'll draw the picture for each one. Because those are the ones that are easy to remember, right? The angles on the axis. 0, right, is there. Power 2 is there. Pi is here, right? 3 power 2 and then 2 pi. So it makes a full circle, right? 10 to power 2, 10 to pi, 3 power 2. Okay, think of it like a animation, right? Okay, if you got everything down, please raise your hand. Okay, and then we're gonna start finding the ratios. Okay, so please raise your hand if you finish the setup. Okay, like this, you can highlight those points. So of course you can fill in more angles, okay, but those highlighted ones are the main ones, okay, that you need to remember. If you have a different color, okay, make use of it. It will make your notes much easier to read. Okay, please raise your hand if you finish setting up the page. Okay, highlight the ones that are on the axis. Okay, and we are doing sine, okay? Sine of each angle. Okay, are you guys done writing these down? Okay, so let's find the ratio for each of the highlighted one, okay? So sine of 0, okay, our first one. Sine of 0. Okay, Daniel, what does sine of 0 equals?
0.
Yeah, okay. And then the next one, sine of pi over 2. Evan. Sine of pi over 2.
1.
Yeah, very good. Okay, next one, when the angle turns to pi, sine of pi, Kellen.
Could you say that again?
Sine of pi.
Oh, yeah.
What do you get?
Sine of pi is over 2.
No, sine of pi.
Oh.
What?
0.
Yes. Okay, you don't sound very sure. Can you try next one? Sine of 3 pi over 2.
0.
No,
Wait, undefined?
no.
I'm not so sure.
It turns to the bottom of the y-axis, right? You look at the picture, right? At the bottom of the y-axis, 270 degrees
Okay.
for sine. Sine of 270 degree, what do you get? Do you know where to find the answer?
I'm not so sure.
You look at the 3 circles on page 43. Page 43, okay? Can you turn to your page 43? You have
Yeah, I'm already on it.
top, right? So sine of 270 degree, what's the ratio?
Um,
Okay, let's go to that page. Do you know how to use it?
yes.
Okay, if it's 270 degree, where does it stop?
Oh, on the bottom x-axis.
It's on the bottom y-axis.
Oh.
270 degree is here, the yellow highlighted.
Oh, you're using sine, then it's 1. I mean -1.
Okay, it's at the bottom. Okay, so the ratio should be -1. Can you try the last one? What's sine of 2 pi then?
1.
2 pi, it will make a full circle, right?
Oh, okay. 0.
Yeah, it'll go back to 0. Okay, so sine of 2 pi. So after that, it will start to repeat again if you keep on turning. Okay, the question we are doing, the example we're doing is sine. So sine has 1 and -1 on the top and bottom, 0 and 0 on the side. Okay, we're using that to get the 5 points. So it starts from 0, goes to 1, goes to 0, goes to -1, go back to 0. Okay, and make a full circle. So now we just follow the points. Okay, we're just gonna plot these 5 points. The first pair is at 0, 0. Okay, look at the plotting now. Okay, the horizontal axis is the angle, and we divide it into each one is pi over 2, and then pi, and then 3 pi over 2, and then 2 pi. Okay, those are the x values. And then the y-axis is the ratio. Okay, we just have 1, 0, and -1. Okay, those are the important points. So if we plot the first one is a 0, 0, right? The red dot. Next one is a pi over 2, 1. Next one, pi 0. Next one, 3 pi over 2, -1. Okay, and then after that, last one will be 2 pi. right? 2 pi is at 0. After this point, it will repeat the same thing again, okay? Continue, go up to 1, go back down to 0. So like a wave, okay? So the way you draw the curve, kind of like a parabola, except is wider, right? So the first half of the circle is open down and then opens up. So you have a highest point at 1, lowest point is at -1. Okay, can you raise your hand if you finish the graph? So it will be a mistake if you draw something like this. Okay, I'll show you what it's wrong to draw. Okay, I erase this first. Okay, if you draw the graph like this, and then you see those 3 lines, 3 points are lining up, and then you draw a straight line. This is wrong, okay? So please do not draw straight lines. You have to show the curve. Okay? Make sure you don't just connect points with straight lines. So you see the way it's curving. The first half is open down, okay? Like a bridge, like an arch, right? The other one is like a cave, right? Like your ball, right? Okay, so you have open up, open down. Okay, if you finish graphing, please raise your hand. Okay, Evan, Callum, Angela, are you done with the graph? Okay, so we can do similar thing for cosine graph and tangent graph. Okay, so now we just focus on sine graph for here, right? So we have several things we need to talk about here. First one is the domain, okay? Domain refers to the x values. In this case, the x, they are the angles, okay? X values, which are angles. As you can see, the angle can keep on turning, right? It can start from 0, you turn, right? Counterclockwise, right? And after one turn, you can still continue to turn. So the curve will just continue to go up and down like that, okay? And you can also turn the other way because angle can also be negative, right? If you turn clockwise. So for domain, for the trig, like for sine graph, it will be all real numbers. Okay, angles can be either positive or negative values. And then for the range in this case is our ratio, right? So ratio, you can see that the highest ratio it can get to is 1. After that, it will drop down and drop down to -1, right? So range will be in between -1 and 1. Okay, please make sure you copy that down. And amplitude. Amplitude is talking about how much it oscillates, okay? The wave, the height of the wave. So in the graph, you can show it here. The distance, okay? The distance between the highest to the middle line, okay? This is the amplitude. Or from the lowest to the middle, okay, to the x-axis. That's the amplitude, okay? So it's like it's talking about the height of the wave, okay? There's a formula to find that. You take the highest or maximum minus minimum divided by 2. Okay, so in this example, your amplitude is maximum is 1 minus minimum is -1 divided by 2. Okay, so 1 minus -1 is 1 plus 1, right? That's 2. 2 divided by 2 is 1. Okay, so in this example, for sine, the amplitude is 1. Okay, next one is called a period. Period is the how long, okay? The graph, how long it takes the graph to repeat. Okay, repeat the whole shape. Okay, so the graph starts from 0, goes up, goes down, goes down, goes up. After that, it will repeat again. So the period is this length. Okay, I use the yellow highlighted. Okay, the length, this is called a period. Okay, the length from the beginning to the end. So for this question, it takes 2 pi. Okay, so a period for sine is 2 pi. All right, and then we have size of space. Okay, size of space is the space between five x values. Okay, the x values that are important. Okay, so it's talking about this part. I'll use the green. Okay, so from here to here, that's a period. No, sorry, that's the size of space. Okay. Okay, and we from here to here, right? In between each of the x values. Same thing with this one, same thing with this one, okay? So it cuts the whole period into 4 equal parts, right? You look at the green line, right? You have 4 equal green lines. The space in between them is always the same, right? So it's the same as taking the whole period. In this case, is 2 pi divided by 4. Okay, well, we won't use 2 pi. Okay, we'll just write down period. You take period divided by 4. Okay, so in this example, we have SOS equal to 2 pi divided by 4. That's power 2. Okay, so these are the amplitude, period, and size of space for sine. Okay, just for sine. Quite a lot of new stuff here. Okay, take your time, look back and forth how we get the whole thing here. Okay, let me know if you have any questions. If not, you can raise your hand. Okay, the new things are the amplitude, period, size of space. Okay, please raise your hand If you have no questions about all these terms, okay? Okay, Eric, are you done writing all these down? Okay, so we are going to do similar things for cosine, okay? Write down their period, amplitude, and size of space, and also to get the tangent as well, okay? So remember the way we got our sine graph? We just use the 0, 1, 0, -1, right? And then we plot the points. So we're gonna repeat the same thing again, okay, for sine. So it'll be much easier. I'll go to next page. So we have three basic form, okay, basic graph for sine x, cosine x, and tangent. So we'll review the sine again, okay? Sine is using this one with 0, 1, 0, -1, right? For cosine, okay, try to remember what are the numbers on there. So our first point, okay, we have 1, -1, okay, make sure you put it on there. And then same thing for cosine, we'll just do sine, cosine for now, okay? Because tangent looks different. So I'll let you guys fill these two graphs by yourself. Okay, make sure you put the x values as well. Three pi over 2. Okay, please plot the 5 points for both sine and cosine functions. Okay, after you've done that, please write down the domain, range, and period. Okay, if you have finished the graph, okay, for both of them, please raise your hand. Right, so let's go over sine, right? Sine, we just did it. So just go ahead. We start with 0, 0, right? Pi over 2 is 1. Pi back to 0. 3 pi over 2 down to 1. 2 pi back to 0, right? You just follow the x and y axis, right? Make a full circle. And remember, the way you draw the graph, please do not connect like straight lines. Okay, please don't do that. It's not a mountain, right? So open down, first part open down. Right, make sure the other side opens up. And we have our domain is all real number, right? From last page. Range is between -1 and 1. Period for this one is 2 pi, right? It takes 2 pi for the whole graph to repeat again. Okay, so for a cosine graph, where is the first point? Angela?
1.
Yeah, very good. Okay, we start at 1 because for cosine, it will start at 1 here, right? And the next point is at pi over 2 and what, Lily?
Over 2 is at 0.
Yeah, very good. Pi over 2 will be 0, so it'll be 0, right? If you look at the axis. And Callum, where's the next one?
-1.
Yeah, at pi, it will be -1, so it'll be here. And Evan, where's the next one?
It's on the 3 pi over 2.
And what about the y value?
0.
Yeah, 3 pi over 2, 0, right? Remember, it's a pair of points, right? A pair of numbers. And so let's go to here, 0, right? So far we got to here. And then last point at 2 pi, Jenny.
Oh, it should be 1, right?
Yep, go back to 1, okay? And after that, it will start to repeat the same pattern again. So remember, for this one, do not connect like a straight line, because if you connect like a straight line, it looks just like an upside down triangle, right? So don't do that, okay? If you drew the graph like that, please erase it, okay? Nick, can you try to draw on the screen how to correctly draw this curve?
Okay. Okay, my drawing is kind of bad.
Oh, pretty good. Okay, better than having a straight line. Okay, very good. So I'll make it more smooth. Okay, so opens down for the first part, open up in the middle. Okay, and Nick, can you help me erase the drawing? And
Okay.
open down at the end. Okay, thank you. Yeah, so that should be the way you draw the curve. Don't draw straight lines, okay? Between every point, you have curve. Okay, the domain is still the same, okay? Everything else, sine, cosine, they pretty much share a lot of things in common. Okay, so real number, you can see the wave is still between 1 and -1. Okay, period is still 2 pi. After 2 pi, it will go back to 0, right? And then go to -1, 0, 1. Okay, so make a full circle. So keep these two graphs in mind. Okay, we'll be studying this a lot in the next 2 weeks. Okay, so what? Just give you show you a little bit of what's ahead of you. Okay, so we're going to add stuff to the equation. For example, like this. We know it's a sine, right? But then we'll add a 1.8, add a 2 pi, add a 3, right? With a negative, and we'll talk about how we get a new graph. So that's why you need to memorize the basic points. Okay, so like I said before, transformation is going to be applied to this chapter. Okay, reflection, the RST, remember? Reflection, stretching, translation, those are going to applied here to make the graph either become taller, right? Flip it, or move it around, right? So some of the question will look like this. Okay, this is a sine, right? And then you look at, I'll show you a cosine question. Okay, like this one. You have -3, you have a plus pi plus 2, right? So we're going to learn how to graph those ones. All right, so that's all for today. We are finishing a little bit early, okay? But that's okay. If you have questions, you can stay after class, and those of you need to do the correction, please stay after class and I'll help you go over it. All right. Okay, I'll see you guys next week.
Thank
Hey, Jason.
Thank you, Jason.
Yeah.
Welcome. Bye. And Jenny, please hand in your homework before you leave.
Okay.
Okay. And Caleb, you're here, right?
Oh, hello.
Yeah.
What would you like me to do?
Yeah, I need you to do the correction for homework 11.
Okay.
Yeah.
All of it? Okay. All of it, right?
Yes.
Okay.
Let me see your home. Let me pull out your home 11 first. Okay. Yeah, so you might need to find out what's wrong first, right? So you need to correct the steps. For example, like question B, the reference angle, I don't know why you put a little 2 on the reference angle for all of them.
Oh.
Square, is that a square? Without a square?
For page, okay, number 11, give me a second. I need to get it out again.
Okay, Yosher, you have questions?
I have a question about identities.
Okay, what is it?
It's like a problem.
Oh, okay. What's the problem? Can you tell me the problem?
It's like sine 2x minus cosine 2x equals 0.
Okay, and then?
And then I don't know how to solve it.
But you want to find the x, is it?
Yeah.
Yeah, okay, so this one, because it has sine, cosine, right? So the identity that connects sine, cosine, there's one identity has that. Which one has sine, cosine inside? The
Both cosine,
huh?
like both sine and cosine.
Yeah. Which identity has both sine and cosine?
Double angle.
Yeah, this one has double angle, yes. Other than that, anything else?
Sum and difference.
We don't use sum and difference for these kind of questions. What else is there? What other group?
Other group.
Yeah, we have the sum and difference. We have the double angle. What else? What other groups are there?
Reciprocal.
Reciprocal, yeah, but this one are not reciprocal, right? Yeah, okay. What else?
Pythagorean.
So that's the square identity, right? Okay, we don't have square here, so that one is also out. What else?
Quotient.
Yeah, okay, so total you should have 5 groups, okay? So quotient is the one we want to use here, okay? Because we can ignore the 2x for now. Let's say we pretend the 2x is like just a, okay? So it'll be looking like that. And if I move the cosine a to the other side, it will look like this. Do you follow so far?
Yeah.
Okay, and if I want to make a quotient, what's the quotient identity?
The quotient for 10.
Okay, what is it?
Sine x over cosine x.
Yeah, okay. So can I make sine over cosine from here? To
You
make,
both sides by cosine.
yeah, so if I do that, then you will get sine A over cosine A, right? If I divide cosine on both sides, equals to what?
Equals to 1.
Yeah, okay. And then now the left side looks like a quotient rule, quotient identity. So I can replace that with
10.
tangent. Very good. Okay, so this whole question just simplified down to tangent A equal to 1.
Oh,
Okay, and once you get here, then you can start solving, right? Tangent 2x equal to 1, and then you do the work.
oh, okay, okay. Okay, thank you.
Yeah, you're welcome.
Thank you, Jason. Bye.
Yeah, bye-bye. Okay, Caleb, did you find the page?
Oh, yeah. I think I know where I went wrong now.
Okay, so let's go over question B first. You do the place right? It's in quadrant 4.
Yeah, I think I had a misunderstanding because, like, I think all you're supposed to do is just find the reference angle,
Mhm.
which is 30 degrees,
It's not.
because it's 60, right? Negative 60. So
No,
the angle should be 60 degrees.
60 degree, okay? And I don't know why you put a little 2 there. What's that? For every reference angle, you write a little 2.
Oh, that's a square. I don't know why I put it there.
Yeah, no, I don't know either. Okay, so you don't need a square. Okay, so reference angle for this one is 60 degree, right?
Mm-hmm.
What do you do next?
You put down the numbers for the sides.
Yeah, which you didn't show that on the picture either.
Yeah, I don't know what happened. Let me just write it down quickly.
Okay, can you also put it on the screen so I can be sure you're right?
Yeah, let me just do it quickly. That